Hi, my name is Mark DeLuzio. I'd like to take the time to show you a lead time reduction model that ties into single minute exchange to die. This is not a session on SMED, single minute exchange to die, how to do a Kaizen, getting into the theory and the practice and all that. This is more a model because there's been a lot of discussion on LinkedIn about this and a lot of confusion, how a reduction in your changeover times will result in a reduction in your lead time and inventory. And by the way, inventory in this case and lead time are synonymous, okay? If your lead time comes down, your inventory comes down, or maybe conversely, if your inventory comes down, it will affect your lead time. So now this is all contingent upon the fact that you're doing, trying to make every part every day. Single minute exchange of die ties into Hijunka level scheduling. You're trying to set over a time horizon, a mixed model, single minute exchange, Hijunka level schedule that, again, you're trying to make every part every day. You may not be able to because of your lead time and changeover limitations, but that's what this model shows you. So it will show you that, for example, a 50% reduction in your lead time will result in a 50% reduction in your lead time and your inventory, your Kanban inventory. So I'm going to give you an example, but before I do that, let me just take a second and stop sharing my screen for a minute and just kind of talk to you a little bit about a quick story. Back in the 90s, I've done many study missions to Japan, and I studied with Nikao and Iwata from Shingijutsu and the rest of the team. And I had, on this particular trip, I had about 30 Danaher executives with me. As a matter of fact, I even think Larry Culp was on this particular trip. He's now the chairman and CEO of GE. And we're walking through a factory, a Toyota supplier, and they made a bunch of, they made all the stuff that went into the dashboard, the vents and the knobs and the controls and all that stuff. So they had a lot of injection molding going on there, whole bank of injection molding machines, but they also then had all this assembly that assembled those, those dashboard kits for Toyota, and they delivered them several times a day. As a matter of fact, just as an aside, this particular company, which they told us Ono had worked there, but this particular company, we were arguing with ourselves whether or not the inventory was turning 300 or 700 times a year. Seriously, that was the argument. It wasn't like, I think it's 4.5. No, I think it's 6.2. No, it was not that. It was not that magnitude. It was unbelievable. This factory is one of the best ones I've ever seen in my life. And I've seen a lot of factories. So as we're going through the factory, I need to tell you this story because this is more of a mindset thing than anything else. We're going through the factory, and the president of the company was leading us. And again, I had 30 Danaher executives behind me, and we're walking through, and we came upon this whole bank of injection molding machines. And I said to the president, I said, geez, I said, how long does it take you to change over your injection molding machine? And he says, it takes us 1 minute, which that kind of blew me away. And I said, well, geez, the best I've ever seen was 15. And that was a Nippon Denso plant in Tennessee, somewhere in Tennessee. I can't remember where it was, maybe Nashville, I'm not sure. But anyway, he said 1 minute. I said, well, geez, when are you going to do your next changeover? I'd love to see that. He said, not till 2 o'clock this afternoon. And it was about 10 in the morning at that time. And so first thing I said, okay, the president knew that. Okay, kind of cool. I said, well, okay, thank you. He goes, well, DeLuzio-san, he said, would you like to see a changeover? And I'm like, are you kidding me? Inside, I'm saying, you do that in one of our plants at Danaher? I was like, get the heck out of here, right? We're not doing a changeover to next Thursday, okay? And no, you can't see it because you don't have 8 hours to spend watching us do it, right? So, anyway, I said, well, Jesus, it's not going to mess you up. I mean, I don't want to, no, DeLuzio said, no problem, right? He calls over his 2 changeover guys that he had dedicated to changeover. Now, this was a big debate a few weeks ago on LinkedIn where everybody says, no, you can't dedicate it's wrong. All the experts like weighed in and all that. And look, that's how I was taught. And then I went to Shingo's book on changeover, and that's exactly what he said. You have to have specialists who are expert in changeover, unless it's a real simple changeover and you don't need a lot of technical expertise. When you're talking injection molding, you do need some pretty high level, technical expertise. So anyway, that was another battle that people all kind of weighed in. And again, I'm just really talking about how I was taught. Right. And also what the book of Shingo says in regard to changeover. So anyway, they changed over the machine. These two guys get up there, they change over the equipment. And I swear to God, it was, I timed it on my watch and it was 55 seconds. So now everybody comes back to me and here's the questions I get. Well, was it a color change? Well, was it this? Was it that? And they try to justify this. Let's just say it wasn't a color change. I think it was, by the way. But let's just say it wasn't. Okay. Show me a non-color change on your injection molding machine that's a minute, right? So when you start getting into these kind of debates with people, you're not going to win because they're just going to try to justify why their changeover takes 5 hours. Okay. And why they're different. That's the other thing. Everybody's different, right? Well, yeah, they are different. They do it in a minute. Okay. That's how come they're different. So anyway, that aside, then the guys, we all clapped, they bowed, took their applause very humbly. Then they changed it back. They changed it back to the part they should have been running. I couldn't believe it. So the president then looks at me and says, Delisio-san, thank you for giving us the opportunity to practice our changeover. And I'm like, are you kidding me? You thanking me? I should be thanking you. That's how they look at it. The old Ollie White MRP model is like EOQ, avoid changeovers, right? And many American manufacturing today and around the world that I've been into different factories in different countries, the game is let's just avoid changeover, which basically means you're going to make stuff you can't sell. You're going to build inventory. You're going to have extended lead times. You're going to have upset customers because of missed commitments. And if that's your goal, just to avoid changeovers, then you're thinking about this all wrong. Remember what he said. Thank you for giving us the opportunity to practice a changeover. And oh yeah, by the way, you don't think the NASCAR and the Formula One and Indy 500 pit crews practice their changeover? That's all they do all week is they practice to get that 1 second out of the changeover because they want to keep that driver on the track. And if you go back to my standard work webinar that's up on YouTube, you'll see how I make the analogy between work sequence and standard work and the driver and the pit crew with changeover. Okay, same thing, right? We want to have water spiders and let the operator operate, let the driver drive. We want that driver on the track as much as possible. Anyway, I'm getting off track here a little bit, but I just want to impress upon you the mindset that this Toyota supplier, the president of this company, had as it related to changeover. Okay, so let me get into the model. Again, I'm not going to go into how to excuse me, how to do a changeover, what a Kaizen looks like. Again, that might be something I do another day. But let me share my screen, if you will, and I will show you the model and show you how it works. And by the way, this model I will email to you at the end. I'll give you my contact details. If you email me, I will send you this model for free. It's I like everybody to have this as possible. So anyway, it's a very simple spreadsheet. Okay, it's not that complex. And so let's just say this is just simulated data. Okay, so let's just say that you've got your Hijunka level mixed model schedule on a piece of equipment. Let's just say it's an injection molding machine. It could be a surface mount piece of equipment. That's a dedicated piece of equipment that serves many parts of your factory, many value streams and all that. Surface mount's a good example. Injection molding, any kind of, equipment where the many value streams go through one central point, and you can't, for some reason, dedicate that equipment to a particular value stream. So they're going to make several part numbers. Now, in this case, I've got 5 part numbers. I got part number, 1, 2, 3, 2, 3, 4, 3, 4, 5. And this demand is my daily demand that I need to make based on my Hijunka level schedule. So I need to make 200 of part number 1, 2, 3. I need to make 100 of 2, 3, 4. Now remember, these demand schedules, and I'm getting a little bit off track here, are over a time horizon because you set your tack time to this demand schedule. Okay. And again, that's always done on a time horizon, which could be a week, 2 weeks, a month, a quarter, depending on your business, depending on the nature of business. Everybody says, well, we can't do level loaded because our business is seasonal. Well, guess what? Every business is seasonal. I have not yet met one business that's not seasonal. Even doctors' offices and emergency rooms are seasonal. Go in an emergency room on Saturday night versus Wednesday morning, you can see a big difference in demand. So every business is seasonal, but you've got to find that time horizon where you're going to set your Hijunka level loaded schedule. Okay. And again, that's conversation for another day, another time. Well, let's just go with this. This is the daily demand in my simple little example here. So this particular machine makes 5 part numbers. Okay. Could make 10, could make 12, right? And here's my daily demand that I really do have to run every day, but I may not be able to run it every day because my lead times are too long. My changeover is too long. Okay. But that's what I need to run. So if I can't run those parts every day, I'm going to need to create a Kanban that I'm going to have to produce and hold so that I can service the daily demand of my downstream customers, which are, assembly, let's say manufacturing, whatever, whoever's consuming these parts. Okay. Now in this column, I've got my runtime in seconds. Okay. And, you engineers out there, if you want to take it out to the 9th decimal place, that God bless you. Okay. You may have to, by the way, if you have a lot of volume, but I'm just using very simple math here. 20 seconds for part number 1, 2, 3, 30 seconds and so forth. Okay. So when I multiply this out, 20 seconds times 200 parts, I have to run this. If I'm going to run it every day, I've got to run it for 4,000 seconds. I also have to run this part for 3,000 and so forth. Now, when I add all this up, I have to run this full complement of daily demand. All this daily demand, I have to run it for 24,650 seconds. And when I calculated this into minutes, you may not want to do that. You can change the formulas just to make it look a little bit simpler. Normally when I do standard work and everything's in seconds. Nothing's in minutes. First, it's hard to calculate minutes because it's not an even number, but we usually use seconds. But I rounded this to minutes because it's easier to visualize. So if I'm going to run everything every day, I have to run these parts for 411 minutes. Okay. Now with no changeover, right? I mean, that's the runtime for that complement of parts. That's assuming no quality errors or anything else going on, right? Now, I came up here for step 2. That's step 1. You get all that math in there. You get all that data in there. And then step 2 is what's your total available time? Well, this equipment is going to run 480 minutes. Okay. Now, I didn't take out breaks. If the operator leaves the machine and the machine goes down and it doesn't run during breaks, you've got to adjust that. But for my calculation here, let's just go with 480 minutes. Okay. And then what's my part-to-part changeover? It's 120 minutes, which is 2 hours. Okay. So if I go from part 1, 2, 3 to 2, 3, 4, it takes 2 hours to change over. Now, people will say, well, we have certain parts that when we go from part 2, 3, 4 to 3, 4, 5, it's only 90 minutes because we don't need to do, okay, fine. Put your average changeover time in there. Okay. The math will work if you do it. Okay. So there's a lot of exceptions, and my example is relatively simple in this case, but part-to-part changeover, let's just go with this, it's 120 minutes. So let's go down and do the lead time calculation. So the minutes available for changeover is this. If I have 480 minutes available and I'm running in one day 480 minutes available in one day, let's say it's a shift, let's say I'm only working one shift, and my runtime for these parts is 411 minutes. per the math on the left. When I subtract those two out, I only have 69 minutes available for changeover. Now, I didn't account for preventive maintenance or any of that kind of stuff, right? But again, you could factor all that stuff into the math if you need to. So my time available for changeover is 69 minutes. Well, guess what? One changeover takes 120 minutes, okay? So I'm not gonna make every part every day. So let's go down below. Days of lead time equals, I've got 5 parts to change over. If I'm gonna do it every day, I have 5 parts. It takes 120 minutes. That means I need 600 minutes to change over 1 day's worth of parts. Well, guess what? I only got 480 minutes during the day. And of those 480, I got to run at 411 minutes. So there's no way I'm going to change over every day, make every part every day, which is the objective, right? So my changeover now is 600 minutes required. That's how much time I'm going to need to do a changeover based on the 120 times 5. Well, since the time available for changeover is 69 minutes, I need 8.7 days worth of inventory in my Kanban. Okay. I need 8.7 days of inventory in order for me to supply the parts, because by the time I make 1, 2, 3, I'm not going to get to that for another 8.7 days. Okay. So I've got to make sure I've got enough inventory to handle the demand for whoever's consuming that part. All right. Now, I'm not going to get into this on this model, but you'll see it when you actually receive the spreadsheet. I've got another tab down here called Kanban Calculation, and it does all the math in terms of how much inventory you need to have on hand. It calculates your savings based on where you are today, blah, 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 blah. Okay, it calculates the container size, the number of Kanbans based on container size and all that. Now up here, here's my lead time, 8.7 days. I should maybe make this a little bit bigger for you. But here's my lead time. There's a safety stock and a buffer stock allowance. And then there's total days on hand, which is 13.7. I really need 13.7 days. And why? What's the difference between safety stock and buffer stock? Now I'm getting into Kanban and all that, which I don't want to get into, but let me just make that mention. Safety stock is what you need based on history, and you can do some statistics on this, as to like when machines break down, when I don't have parts, whatever the case may be, that does not allow you to continue to run, not changeover, all kinds of stuff that would shut your equipment down, that type of thing. Buffer stock is allowing for deviations in your demand. So even though you have a Heijunka level schedule here, you might have some deviations in your demand, and that's what the buffer stock is all about. So obviously you want to try to drive these down to zero, get a good sales and operations planning process, do good TPM, and try to eliminate these two numbers altogether. But I'm a realist, and I did allow for this. So in reality, instead of 8.7 days, we need 13.7 days in my example. Okay, so I'm not going to get into this whole spreadsheet. You can look at it, and if there's any questions, you can call me. But that's, I just want to let you know that translates into how you would set up your Kanban for that particular piece of equipment. Okay, so let's go back to the lead time calculation. Now, when I told you that, if we have a 50% reduction in changeover, it will result in a 50% reduction in your lead time, okay, and in your inventory. So let's do that. Let's go to the 120 minutes up here and just change the variable. Let's make it 60. I did a Kaizen, I took out 50%, and I'm going to make that 60. Watch what happens to the 8.7 down below. Right down here, when you're looking at the lead time, watch what happens. Goes to 4.3. That's it. Let's say I take this down to 10 minutes. 0.7 days. I'm eventually going to get to a point where I can make almost every part every day. Okay, that's almost that, right? It's almost that. So, if I went down to 5 minutes, let's say, okay, I virtually have very little inventory in my Kanban. Now, I may still have some with the safety stock stuff that in the buffer stock I talked about earlier, but you get the point. A 50% reduction, an X% reduction in changeover, given all this assumption with level loaded, Hajunka, and all that, will result in a 50% reduction in your Kanban. Okay, and by the way, one of the things that Nikau taught me, he said, Kanban is a mission of failure to do one-piece flow. Okay, obviously we can't do one-piece flow here because we've got long changeover times. So he said, Americans love Kanban, and you should first look to see if you can flow before you have to put a Kanban in. Don't just automatically default to Kanban. That's number one. Number two, he said, Kanban should be used as a vehicle for improvement. So here's how he taught us. He said, and let me put the 120 back in here for a minute. I'm back to 8.7 days, right? He said, go to this Kanban sheet and challenge yourself. Say, hey, I'm going to pull out so much inventory from the Kanban. What would that tell you? Oh, geez, why can't you do that? You're going to shut your operations down. All of a sudden you said, well, why am I going to shut my operations down? Well, if I take half the Kanban away without doing any Kaizen, including SMED, okay, you may sit there and say, well, I can't do that because my changeovers are too long. Oh, great. Put that on your Kanban list. Machine goes down. Good. Put that on your Kanban list. Not a very reliable supplier. Good. Put that on your, I want to say Kanban list, Kaizen list. Put that and start asking yourself, if I reduce my Kanban by 50%, what are the reasons why I can't do that? And once you start laying out those reasons and prioritizing those reasons, there you have your opportunity for Kaizen. And that's how you should set your Kaizen. So that's what he means by using Kanban as a vehicle for Kaizen. Challenge yourself. I want to reduce my Kanban by 50%. What is that going to mean for me? Besides shutting down my operation, that will unveil your opportunities. Okay, now you see how the difference in the change in part-to-part changeover or the SMED time, the changeover time, directly affects your lead time. Right now, let's do something else. I put it back to 120 minutes. I'm back to my 8.7 days. Let's say I do machine Kaizen. And I come in here and say, I could take speeds and feeds out on a CNC, or I can reduce the travel time or reduce the cycle time on a particular part, okay? Or even the load unload time. I can get better at that. That's an operator thing, but it still affects your overall cycle time or processing time of your equipment. So let's just say I go in and do some Kaizens and I say, okay, well, at 20 seconds, I took 3 seconds out and make that 17. And that 30, it's 25. And that 15, geez, I got it down to 12. And that 20, let's just say I got that down to 17. And that 22, let's say I got that down to 18. Okay. What does that do? It took my runtime down to 340 minutes. When I go through the algorithm over here, you can see now I have 140 days available for, 140 minutes available to do changeover as opposed to what I had before. And when I go through the math, you can see now I only need 4.3 days of inventory. And that's my lead time, okay? So just by looking at machine cycle time has the exact same effects as changeover time, but nobody looks at that, okay? Nobody looks at cycle times. Now, if you look at cycle times on your equipment, if you can do it, and again, you don't want to compromise quality because you could do that if you're not careful, all right? And make sure you always have a good engineer with you. And then I come back and I change over to 60 minutes instead of 120. Now look what happens. It's a double whammy, right? Now I'm down to 2.1 days. So the synergistic effect between cycle time reduction on the equipment and the part-to-part changeover, the SMED time, has an unbelievable impact on your lead time and on your inventory, right? So you want to know how changeover really does affect your lead time. Here's the math behind it. Now, one of the other things I'll ask you to do, you actually do, you can take this model. Let's say you had a bank of like 6 injection molding machines. and let's say everything's interchangeable. Sometimes they're not, but some of this equipment you can kind of put the same mold on different machines. You could take this model and lay 6 of these side by side, or 5 or whatever, and actually do some what ifs. Hey, let me take this part number and put it over here. Maybe you want to just put a high runner on one piece of equipment and not have to change over as much at all. And that's okay, as long as you're not overproducing. If you got the demand to justify running the thing, 8 hours, there's nothing wrong with that, okay? But the point of the matter, though, is you could do some modeling by taking a number of these different spreadsheets, laying them side by side, and doing some what ifs. Hey, I'm going to move part number 1, 2, 3 over to machine number 4. What is that going to do to my overall lead time in my inventory? And you kind of play that game, right? And I've done that before too. That's kind of fun as well. Okay, so that's the deal. Now, one of the things I want to share with you is that if you feel so inclined, and you want a copy of this model, feel free to email me and let me know who you are. Okay. I don't want to get an email that says hotmama@hotmail.com with no name, because you're not going to get this. Okay. I want to know who you are. But, here's my contact details down here. Mark.DeLuzio at Lean Horizons. And you can look me up on LinkedIn and all this good stuff, right? But I will send you this model complimentary. It's all this is an Excel file. This emails to you. And like I said, if there's any questions, you can call me. And of course, my book, Flatline, that I've written now going on almost 2 years come April, but it's doing very well. And I get a lot of good comments on this book. Why lean transformations fail and what to do about it. Okay, so please, again, if you order it and you have any questions, please let me know. Just email me and let me know, and I'll be happy to reach out to you. So the last thing I think I want to say is, before I close this off, is the inventory. This model is simple, but it's helpful to explain to people why changeover has the impact it does, right? And unless, some people are very visual, and I am too. Once I saw it, once I laid it out like this and did really some deep thinking on this, it was easier for me to see. And it's also easier for me to explain to people, the impact that changeover, can have. Now, obviously, the best changeover is no changeover, right? So always try to flow first before you put in the Kanban and that type of thing. Now, somebody else asked a question about, I think it was Rebecca asked a question on LinkedIn. What about if you had a cell? This can apply for a cell too. Okay, this can apply for, let's say you have equipment that feeds each other. Okay. But it's still the same concept. You're going to produce a Kanban outside of that. This whole thing works the same way. Okay, so it could be done there. Typically, when I've used this, though, it was on a single piece of equipment, like a die casting machine, a injection molding machine, as we talked about, surface mount equipment, that type of thing. So, it's funny, you're talking about flowing. When I went to Yamataki Honeywell in Japan, they built their own surface mount equipment and put it inside the assembly cell. It was about this big, it wasn't all that big. And usually surface mount equipment is a big thing, what requires a big changeover and all kinds of complicated reels and parts. And they just said, hey, look, we're going to build our own surface mount equipment. They put each little machine, about as big as a sewing machine, into the cell, and they flowed it. It was unbelievable. It produced the tack time and everything else. So you can even take something like that. I've done it with wave solder. We built our own equipment where the wave solder machine wasn't a batch operation. It was a one-piece flow operation. And we actually built the machine. Most wave solder machines are really big, but we built the machine so that the machine, it was our design, went to the back of the cell outside the U, so that all the operator had to walk through was a spot about maybe 2 feet, where they would load the part in one thing and the other part would come out right next to it. And all they had to do was load, pick up the part, and move on into their work sequence with standard work. So again, you don't want to have a lot of walk time in the cell and lay a big wave-sided machine out where they have to walk, 6 feet past it just to get from one end to the other. So the more you can put stuff outside the cell, and again, I'm getting into cell design here. I think you're going to see here when I talk about Kanban, single minute exchange to die, standard work, hierarchical level scheduling. We didn't get into 5S or visual management because, of course, 5S, SMED begins and ends with 5S. Talked just now about cell design. These tools don't stand alone. They're eclectic. They're all one big Venn diagram. So I really can't talk about one thing without bringing in other concepts and other tools, right? So, and that's one thing that our consulting industry likes to do. They like to sell separate tools. And that is so wrong, because you've got to look at this as a comprehensive approach, because they all kind of talk to each other. They all tie together. Anyway, you've got my contact details. If you have any questions, this obviously you already know you're watching this on YouTube, but I'll be putting this up on YouTube and be happy to answer any questions on this. And I'd be interested to find out how you guys do with this and see if it works, and see if you got to get some benefit out of it, right? Anyway, thank you. I'm doing this a couple of days after Christmas, so I hope everybody who celebrates Christmas had a great holiday, great Christmas, Happy New Year, and I look forward to hearing from you sometime in the future. Thanks. Bye-bye.